Nathan Hamiel.
Thanks. I only expected 3 people to be up this morning, so thanks for coming out or not going out and drinking last night or being stuck here like I am because my flight was canceled too. This talk is about attacking APIs and application extensions. It's kind of early in the morning, so there's going to be some things in the slides that I'll probably take out later before the distribution to wider media. What this talk is about from a perspective of APIs is the APIs that you would create to connect and add functionality to your application, not APIs that are inside of programming languages that you might need to hook to for functionality. So I just wanted to clear that up a little bit. That was a lot nicer than the one I had in here, which was a little, maybe I'll show it later. So I am Nathan Hamiel. I am a principal consultant for FishNet Security on the Application Security Group. I'm also an associate professor at UAT, and I founded Hexagon Security. And we don't really do much at Hexagon Security except go to conferences and hang out and talk, and every now and then we'll release something. So the net, from the early days of the net, we've all seen diagrams like this, these interconnected computers, but from a network level. And, if one node on the net goes down, typically it doesn't affect something on the other side of the net from that perspective. And this architecture has been in place for a very long time. And it's really been figured out. So, we've kind of got that whole deal figured out, and there's lots of redundancy and everything else. So typically it's pretty good. But lately, what's been happening is there's been an increasing amount of connections at the application level. And this becomes very interesting because of the attack surface. So we haven't quite gotten this whole application level thing figured out. And that's where a majority of the vulnerabilities are right now. And for some reason, all this interconnected functionality isn't really being properly validated. So even if you're doing something as simple as piping in an RSS feed into your application, how it's rendered on the page can be very problematic. It was not too long ago where the New York Times had like this feed reader where it would pull in a bunch of feeds. And there was an article on HTML injection, and it kind of encoded the characters. Well, when the feed went out and grabbed that feed, it actually performed HTML injection on the New York Times site, which is like very bad. So even though one site was doing it right, when that content got piped into another site, it was actually done incorrectly. And these are the kinds of things that that as developers they should be thinking about, and as attackers we should be thinking about as well, because when we're testing these things, we shouldn't make assumptions that everything has been done properly or that people have thought of even the most simple rudimentary things. And during this talk, I'm going to talk about specific examples of violating API structure and some, examples of that. There's really not a lot of, ODA dropping things in this talk, but if you test web applications or you develop web applications, hopefully it's pretty useful. So this connecting at the application layer, we have this mesh of content versus, traffic. So like I mentioned, RSS feeds. It also increases your attack surface. And content delivery goes far beyond, a user, functionality on your site. So if they were uploading pictures or sending messages, that's content. But also advertisements are content too. And there's been an increase of that lately as well, where people are buying ads, malicious ads on popular websites, and if not delivering attacks, they're definitely delivering things that aren't very nice. Pop-up windows that say, you need to go here and download this because your computer's about to die in 10 minutes. As well as less validation with higher trust. So when a developer decides to write something that pulls content in from an external location, it's seemed as being at a higher trust level than if a user makes that decision. So we all know that developers make mistakes too. So there's a lot of assumptions being made about the content that gets delivered on a site. Whether it's hooked in through an API or pulled in through a feed, these assumptions will actually kill you in the end if not taken seriously. So kind of this simple diagram of an API, it provides a content layer and delivery method for services and data on the back end. So it's this uniformed interface where you make calls and you hopefully get what you want. The reason there's so many vulnerabilities at the API level is because they're not thought of as being part of the application. So when you're having an engagement, or whether you're doing third-party validation, a lot of these times these things are not scoped into the assessment work, or they're not really thought of, and that can be a problem. And I think it's because a lot of times these aren't thought of being consumed by users; they're consumed by other applications. So there's a lot of assumptions there. And lately, since the popularity of extending these applications, you may have a legacy application that now needs to be extended, or functionality that existed in that legacy application that now needs to be consumed by a third party. And where we started seeing that was mobile. So in the early days of mobile web browsers, you had this, this really small screen and this really horrid, atrocious web browser that basically was only one step up from Lynx. And well, actually, Lynx actually had more functionality than that. So there had to be these separate interfaces created for them. So if you wanted to do online banking, you'd go to a different, URL that had different functionality for your mobile device versus, just visiting the web page with a web browser. So that's where we started to see some of this. And, now we have APIs for clients of varying girth. So these fat client applications are now using HTTP as a transport mechanism to send data back and forth and provide this functionality. So when you bolt on an API to an application, there's a lot of thought that needs to go into how it integrates. Mainly because you can fix things in one area and they're still vulnerable in another if you're creating these multiple paths to the same functionality. APIs have the same problems as traditional applications. So from authentication, authorization, session management, accountability. Accountability is a big one because a lot of times API calls don't get logged. So if they don't get logged, when they're being abused, you have no idea they're being abused at all. Authentication and authorization are kind of interesting because when that gets tied into the application, when they're aware of each other's session data, that can be an interesting area for vulnerabilities as well, how that data gets passed back and forth. And I have a couple examples of that later on. And these APIs are often not fleshed out at implementation time. So where you see this more often is they have more or less dev code in production. So they're still figuring things out, but they pushed it out because of some time frame basis. And that goes back to lack of proper testing too before it makes it into production. So for API services, there's basically two types of APIs when we're talking about from an application level perspective. You have consumption APIs, which allow something to connect to your application and consume services. So say you had a currency conversion service that you were offering. This would be defined as a consumption service. So you can connect, you can send the appropriate data, and you get the appropriate response. So I now get my currency converted. Integration APIs are what really becomes interesting for an attacker because you're taking external content with a call and placing it in the direct path of a user, which is often what you want to do as an attacker if you are exploiting something like cross-site scripting or cross-site request forgery, because when you put content in the path of a user, there's a couple of knowns at that point. As an attacker, you would know that the user is running into your content on a specific site. And if it's integrated after the user authenticated, now you have an authenticated user who's running into malicious content, which is pretty much win for an attacker. And of course, there's the one API to rule them all. So there's nothing saying that your API can't provide both consumption and integration. Probably one of the most simple to understand is Twitter, right? Twitter is a very simple web application. However, it allows you to use third-party applications to, get your messages, and it allows you to then integrate content back in. So you're sending messages that then end up being integrated on their site. As you might imagine, APIs make great targets if you're an attacker. basically because they increase your attack surface. And that could be over doubling the amount of inputs you have. You may extend the application so far that for every input to the application, there's an associated API call for it, and then beyond that, you may have functions that aren't available to regular users that are now available through the API. So maybe a regular user can perform all these functions. Let's say Twitter, for example. Maybe a user can add content and get their content, but if you have API calls, maybe you can see the rate that the person posts, or maybe you can get trends that weren't available through the regular interface. So now you're creating more inputs that then have to be validated and checked. The typical depth of an API is more than a standard user. So the user may have a set of functionality that they have access to, where the API is far beyond that. And if you think about it, a user to access functionality may have to go through like 4, 5, 6 different menus to get to what they're trying to do. Like say for instance they were going to send a message to somebody. They would have to log into the application. They would have to go to the messages menu. They would have to hit compose. They would have to add their data, and then they would have to hit send. Well, add a data, add a recipient, and then hit send. Whereas an API call, it might be one call. So now you have all of this functionality in one specific location, very easy to consume. And as you might imagine, if you have more expanded functionality, you also have elevated privileges. So you need to have elevated privileges to consume these extra sources. And what comes along with elevated privileges is higher trust levels. So now your API is operating at a higher... I love that picture too, by the way. I mean, who wouldn't want the king hitting on them, right? So you have higher trust levels. So as going back to people making assumptions about content that are coming into the application, those assumptions are assumptions at a higher trust level because it's seen that applications and other developers are consuming resources and not users. However, they're not thinking about the things that are leaked to a user through just standard calls. So there is some good news to all this, and it's that people are using standard protocols and data formats when they're creating their APIs. So there's not a lot of reinventing the wheel from that perspective, which is good because some of these things we've kind of already fleshed out. Like data formats is probably not, we probably don't need to use some, weird binary format that, we created ourselves when connecting to these things. So there's less vulnerabilities from a reinvention perspective, so you don't have to worry about things at that much lower level. And they're also readable and understandable. So if you don't know what JSON looks like, it's very easy to find out what that is from a couple of searches. And it also means, your standard common tools can be used to analyze API calls. So you can use, your standard Wireshark, Burp, WebScarab, whatever you want to analyze these. So what I kind of came up with for API testing was a simple little method to go through and identify the presence, the purpose of the API, the structure of the calls, and then of course violate those structures and then evaluate the results. So most of the rest of the presentation deals with either identifying the purpose and structure and of course the fun part, which is violating that purpose and structure. You basically have two methods for identifying APIs, as you might imagine. There's zero knowledge and documented. So zero knowledge would be for kind of internal APIs, and documented is pretty self-explanatory. And since I didn't want to put anything else on this slide, I just figured I'd add that in there. Ninjas are everywhere. And since APIs are meant for consumption, most often there are documentation laying out there somewhere, even if it's not meant for you to see. Because we all know that people only put appropriate things on websites, right? Like nobody would ever put documents to, default passwords for ATMs or anything like that on their corporate website. So you might be surprised when going through and doing testing, you might run into documentation for APIs that aren't published publicly. And that can be win for everybody. Well, if you're the testing team, it'd be win for you. So you can search for applications using search engines, pretty obvious. So if you didn't know Twitter had an API from just Googling for Twitter API, you might notice that, hey, well, I use a Twitter application on my phone, or I use a Twitter application on my desktop. So it's probably making some form of calls to an API. You can also check the site, because people are very happy when people create applications that interface with them. And you can use tools, because it might not be obvious that you have a widget or something installed in your web browser that is making calls to an API. So I wouldn't know that most people that install, say, social network applications, I would say that most of them wouldn't know that they're making some sort of backend API call. But you can see those if if you're doing a inspection proxy in your browser, like you'll see those calls going out. And from a zero knowledge perspective, most of the reason why those aren't published is because they're for internal use only. So maybe, like say Hulu, for instance, maybe they only want to create a desktop application that they can use, and they don't want to open it up to everybody. Or maybe they want to have some sort of developer vetting process, so not just anybody can create an application that interfaces with their service. Because sometimes that kind of makes sense, because you have people creating like crappy applications that then make your service look crappy. So that kind of makes sense. And documented is where you get obviously full win. And that's typically the case, because people put this stuff out there. So, because the larger user base, the more popular your application becomes. And that's really what it's come down to. Everything nowadays is integrating with something else. There's not a lot of static websites left out there. So it's all about a functionality arms race between you and your competitors. So that's pretty much what it's come down to. And what you also get with not only identifying that, one, there is an API there, and two, structure data, you also get architecture information and capabilities of the API. So when you're going through looking at the API and you're doing kind of this functional review and you're trying to determine, hey, I want to know what this thing does and how it does it, you basically have that all documented there. It's your capabilities and the depth of the API into the application. One of the things that Google came out with was Open Social, and it was originally meant as an API for social networks, and then they decided that, hey, this is a great idea. It's not only for social networks anymore, anybody can use this API. There are some people that think that, wow, all of this functionality I get with this API just isn't enough, I need more, so they'll end up extending the API even further. So those are things that you would find with documentation as well. So even if you recognize that somebody was implementing Open Social because maybe you saw some Google-oriented type code in there, just be aware that they may have extended it even further. So it might go even deeper into the application, be way worse than you thought on the surface. Because when you implement somebody's third-party API, you're swallowing up all this functionality that they originally intended, which you may not even need. And typically, it's the kitchen sink up front, and then you just kind of take off what you don't need. And in that case, you may be allowing people to make calls to things that you never intended them to make calls to. So you get that, you get the extended API documentation, and you also get case information. So not only would it tell you how to do something, it would probably tell you why to do something. So in this case, you would want to do this. One other type of API that would be hard to identify without any documentation would be server-to-server APIs. So if you kind of have something in place where content from another server is being called and placed onto another server, there's no client-side interaction with that. So from a testing perspective or from a user perspective, you would never see the data going back and forth between servers, because none of that is like leaked to your web browser or your client that you're using. And also with documentation, you get some win from modules that make calls to the API.
So what about latencies for server-to-server communication? Are there going to be a lot of things you can deduce from timing to be able to tell whether or not you're actually having back-end calls?
Whether it's making back-end calls, you could. But as far as like structure and how it's happening or what the calls look like, the question was, what about latency for back-end calls? Would you be able to deduce that something is making a call there? It would depend on the site too, because maybe you're used to it being horribly slow. But it would really be hard to identify the call and what the call looked like without any kind of documentation.
A good example would be Amazon. I know for a fact they, when you pull up their main page, they make about 250 back-end calls.
Yes.
Right, so they scatter them all at once and gather them back together. And obviously they're not a slow site.
Yeah, exactly. Yep.
If it's well implemented, you're going to have a really hard time seeing whether it's, but if it's a big site, it's obviously not.
Mm-hmm.
You
Well,
can't scale it on one box and therefore.
also, too, back-end server calls on the same network are obviously going to be much quicker, too, than back-end calls that are going to different, servers around the web. So that would be another thing, too. So these language-specific modules will also help a lot if you're trying to create a malicious client and do things like that. Obviously, popular languages like PHP, Python, Perl, and others as well. And I decided to put a couple examples in the presentation you can click on later to kind of mess around with, because I'm talking about it kind of almost from an abstract perspective. Like, I've talked about APIs, but I haven't shown what any of this looks like. So hopefully I'm not getting too many glassy eyes. I don't think so, but so there's a couple for some popular websites. When you're going through the documentation, or whether you're using a zero-knowledge perspective, you might notice when you light off your web browser and you load something up and you're inspecting everything that's going on with an inspection proxy, you might see tons of calls everywhere. So you'd really have to pick and choose which ones are kind of calling APIs or which ones are calling functionality that you weren't aware of. You're going to want to not only determine the depth of the API into the application, but also what functionality is available to the API that aren't available to your quote-unquote standard users. And usually those are for, require elevated privileges. So those are going to be interesting. Also, is there any segregation between the API calls and the actual application itself? Because that would definitely cause a problem. So if your API and your application are one and the same, basically, and you're integrating content, now all of the content that you're integrating into your application is now rendering on the same canvas if it's a web application, which can be very bad, as we'll see later. And basically what I just said. How is your content integrated? Is it integrated into the same domain? Is it rendered on the same canvas? Are you creating multiple pathways to similar functionality? And where that becomes a problem is when it comes to fix time. So if you find a bug in something and you fix it in one spot, now you need to fix it in multiple spots, which often gets forgotten about. So you may have a bug that you identified a year ago that's still available through your API, that because of and bugs not only from a coding perspective, but from a session management and authorization perspective. So you may be providing standard users with elevated functionality through an application, and through the standard interface that you developed, they don't have that functionality. What is the structure of the call? Like, what does it accept? What types of data formats are you dealing with? So once you understand that, it makes it a lot easier to understand how to violate it. So obviously, if you're using like SOAP, you know that there's supposed to be a standardized envelope, and if you mess with that too much, you know what you should expect to happen. But you can do all the same web application attacks against API calls that you can against standard applications. So if you're talking about trying to do some things with JSON or XML, those are defined formats, and if you can violate those, then it's win. And also the type of transport. So what type of service are you dealing with when you're sending data back and forth? So here's a simple API call, and this is one that I did a while back when I was messing with Google a little bit. So there are a few things that you should notice about this, and hopefully it's big enough for everybody to read. One is you should see it appears to be a standard HTTP GET. So that should be pretty obvious. So this whole thing is contained in a GET request. The other obvious thing that would be interesting if you were testing is you should see that it's a call from one domain to a completely different domain. So it appears to be pulling content through something called a proxy, which should be something else that would be interesting, and it appears to be retrieving that content. You'll also know that where it says OpenSocial_URL, you'll also notice that somebody thought about content encoding on that. So it's URL encoded, and it appears to be signed with a token. But that doesn't mean anything because even though it says auth type equals signed and there's a token, this was something that got horribly violated during a different talk in 2008 that we gave at me and Sean Moyer, purposely pronouncing his last name wrong because he used to do it to me all the time. Me and Sean Moyer did at Black Hat 2008. So that's what, and throughout the rest of the talk, I'm going to use like simple examples of, just a standard get to show how these things are violated. But it could be in any format. So here's an example for Delicious. Can anybody tell me what type of web service this is? From looking at it? There you go. If I had a prize, I would give it to you. It's a RESTful web service because it's using all of the methods. It's using get, post, put, and delete. So, and just from looking at this should be interesting is that it doesn't say anything about authentication, like in just what I showed you. It doesn't say anything about authentication and session management. So, if you just decided to post out to add a bookmark to quote unquote username, what would happen? And those are the types of things that you want to be thinking about when you're testing. Is anything that seems to be static in nature, especially, anything static should be attacked. It should be violated. The structure should be analyzed. I'll get into that when I get into the fat client stuff. And of course, bolting on, which is popular with people who have had applications out there for a long time and now need to provide some sort of functionality. Even if it's not for external consumption, even if it's only for internal consumption, bolting on APIs there's nothing wrong with doing that. It's just the thought process and the design needs to be there because fixes are often not integrated and you're once again potentially creating multiple paths to the same functionality. What I've seen happen quite often is the wrapping of services. So you might not want to create your own instant messaging framework or chat framework within your application. So you may look elsewhere for services that provide that, and then you might want to wrap it in your client. Well, that's all well and good, but when you're wrapping something, you need to be aware of all of the functionality that's available. And from a tester, that's great because usually these other services are very well documented. A simple example would be, I have a site and I want to create a chat framework and instant message framework, but I don't want to write the backend code. So maybe I'll wrap Jabber up in my front end. But Jabber has some interesting things by nature because it's open. So if you weren't aware that you can just register as a new user by just, registering on the Jabber service, that could be a huge problem. Because now you have extra functionality. Also, think about the fact that maybe you can use your own client to connect to that. And yes, once again, I am standing up here talking about something on Adult Friend Finder. It's just funny to me, but that is using iChat to connect to the Adult Friend Finder messaging service because it's just Jabber. So they had this intricate front end that was written in Flash that I never did fully take a look at. I just noticed that it was calling Jabberport, so I assumed that it was Jabber. When I lit up iChat, I directly connected to it, and I found out that the security policy that was pushed, basically, the restrictions that were placed on the Flash client were no longer there because I had used my own messenger to connect to that. So those are the types of things to think about when testing services that appear to be wrapped or when you're in the design phase of doing, implementation. So identify functions that you definitely don't want your users, taking advantage of, and, putting in place restrictions properly. So fat client applications. Increasingly lately, we're having more and more fat client applications that are just using HTTP as a transport protocol, which obviously there's nothing wrong with that, but that opens up some things as well. So one of my favorite things is Dropbox. Now, I love Dropbox. I use it all the time. I love their new shirt contest, which this was actually on a shirt, and it says, "It just somehow works," which is kind of how sometimes we take everything. It just somehow works. I just know I drop things in this folder, and automatically it gets synced online through some form of magic. But just because it's a a fat client application doesn't mean there's not client-side functionality that we can't analyze and take a look at how it's used. And so from that perspective, you may notice if you use Dropbox on OS X, you can right-click on files in your Dropbox, and there's a couple of options where it says browse on Dropbox website and view previous versions, because there's version control with Dropbox. If you click one of those links, it automatically opens your default browser, logs you in, and takes you right to the page you want. So that's kind of interesting, right? Because you now have a fat client application that somehow knows session data that gets transferred back and forth between the front-end website. So that's definitely something you'd want to look for. Also, too, if I have my blog at the end of the thing if you want to find out about predictable resource locations as well with cloud apps. Hulu, who actually, first of all, who uses Dropbox in here other than me, or who will admit to using it at least? All right, few people. All right, very good. I haven't found anything devastating yet, but I haven't really looked either. So, I mean, I encrypt stuff, some of the important stuff before I go to it. How many people have at least heard of Hulu or watched Hulu? Anybody use Hulu Desktop? Okay. So at first, Hulu Desktop looks like kind of a fat client application, which I guess you could kind of say it is. But if you download Hulu Desktop and then you kind of inspect the traffic, it's basically just making a call for a Swift file. So it's just Hulu Desktop.swift. So those are kinds of things to keep in mind too when you're analyzing, clients that connect back to web apps. How is that content being rendered on your system, and how can that be violated? So who here uses Pandora Radio? Wow, I expected that to be a lot higher than Hulu. Wow. Well, Pandora, they typically have a fat client application. Well, kind of a fat client application. It's an Adobe Air app that if you subscribe to their Pandora One service, they'll give you. And I didn't do that, but for OS X, there's a program called Pandora Jams. So I was kind of interested at how that talked back and forth to the Pandora service, and that's really easy to find too. You just light up Wireshark, and then you can see it's passing data back and forth with XML. So that's kind of some of the ways you can identify the structure of calls, analyze any kind of client-side functionality. So for something like Pandora, there's different functions you can take advantage of through a quote-unquote fat client application, and it sends it back to the web server. Adding a playlist. Well, logging in is the huge one. Adding a playlist, searching for different artists, things like that. So let's bring on some fail. I found that last night, and when I was thinking of how early it was going to be, and maybe there's a couple laughs that needed to be had. So I just, I don't know, I can't go past this slide for a second. It's just awesome. When thinking about how external content is rendered into a canvas, it can be very bad. So this is an actual older screenshot as well of the social network MySpace, and how they handle content segregation is they're basically like, we don't want you touching our stuff, but you can touch your own stuff all you want. And oh, by the way, you can touch other people's own stuff too. So they have this api.msappspace.com domain where they just shove all of their applications, which is really fun if you're an attacker, because it used to be really easy to become a MySpace developer. You just ask them, and it's cool. So, and I think to this day I still have a developer account, which was really bad after Black Hat when they all came up to us. But anyway, you can call other built-in functions from other things that are rendering on the same canvas. So depending on when things are rendered in the browser, but definitely cookie information. So this screenshot is me calling a cookie that was set in another application called pants status. Now I was gonna write this application called pants status because me and Sean Moyer were talking about how funny it would be to have an application called pants status, and it would just say currently down for maintenance, it would never work. So pants status currently down. But then I was talking with Sean last night, and we thought that maybe it would be fun to have it and then say currently on the ground, but I don't know. if you have shared APIs, be aware that they can be violated and turned into an anonymous proxy. So if you have these consumption APIs that grab external content and then are rendered for users, you can also use that and not care about the rendering whatsoever. So a while back when I was looking at OpenSocial, I found out it was very easy to call other people's APIs. So it was rather fun one night when I was seeing like how many I could call at once. So like I would call one from like MySpace, and then I would get it to call friend feed, and then I would try to get it to call, you know, other things, and they were actually working, which was kind of crazy. But you could, if you had some form of data you wanted to send somewhere, and obviously your mileage may vary depending on the API. So you know, you may be dealing with APIs that are developed in-house, and there's not a framework that's been adopted. So when a framework's been adopted, obviously fixes get integrated really quickly. And what that would look like is something like this. So you would see an API call, and this is high five. And a lot of these are OpenSocial because it's really easy to understand. So like standard HTTP GET. So you'll see something in here that says URL equals target and HTTP method equals GET. So if you place things in the URL equals target, as long as it's properly encoded, which this example isn't, as long as it's properly encoded, it will just send data because it's a proxy function. So it's going to do what you say. Proxies are very helpful because they go do things for you that you ask them to. It's like, please send crap here. Okay, thank you. I will do that. What else is really fun is if you change the location to 127.0.0.1, you find very interesting results. This is the localhost dev page on the proxy box that was making the function. Where this becomes really interesting is now you have a machine that is making calls for you that's behind any kind of filtering devices. So other machines, if you, like for instance, if I wanted to know the public IP address of this proxy box, I could call whatismyip.com and it will return its public IP address. From there, maybe there's other subsequent public IPs that are right next to it, or you can try to enumerate through private IP addresses too, which obviously becomes a lot more fun. And there may be some sort of trusted connection between this box and something else, which there shouldn't be. It's a proxy box. But, you know, well, actually, it would never happen, right, because everybody does things properly. So with this call, when you're calling things like 127.0.0.1, there's nothing saying that you can't add a different port number onto this as well. So, hey, that can be a lot of fun as well. And there's nothing saying you can't add other ports for other systems behind that as well. So it would be really easy to script something together, and I have done it in the past, that will go through and check for different ports and check for other, you know, public and private IPs on the same network. Oh, and just as an example, I'm doing everything here is unencoded for just ease of on your eyes, because it looks really crazy when you start encoding things. So that's the other thing about understanding what the API is expecting. Because if you're asking it to try to bring back something that's semi-legitimate, you need to know how to tell the function to return it for you. So the URL equals, if you remember in the example before and then in this one, the URL is encoded in some way, shape, or form. So you might end up with something that looks like this. So you just need to decode it and find out what it's calling. These are also fun. These are API direct loops. So it's possible to get APIs to call themselves over and over and over again and never stop, which can be a lot of fun. And what's funny is sometimes these things are thought about. So like Google with OpenSocial is, they're like, well, you know, they had this figured out with browsers a long time ago, like you shouldn't infinitely follow redirects because that's just ridiculous. So they kind of thought, well, you know, in our proxy functions, we probably shouldn't follow more than 7 redirects because that's just ridiculous. However, if you make the API call itself again, it's only 1 redirect. So yeah, obviously they didn't think about that scenario. And for every subsequent API call, there isn't a redirect at all. So if I have API A call API B, there's no redirect there. The only redirect that would happen is when it gets redirected back through the loop again. And what that looks like is something like this, and this is unencoded as well. But there's nothing saying that the API just can't call itself over and over and over again because the API never sees the redirect. There's never a redirect there. So yeah, that's bad news. The only thing you're really limited by is the length of the URL, and if your browser cacks, or if there's something in the API that restricts the length of the URL. But if there's one redirect in that loop and you're not violating any of those, it'll just keep going and going and going, which is always fun. So I'm going to talk about a couple of examples from 2009 where people just are doing it wrong. Okay, got 15 minutes. Does anybody remember this OAuth session fixation vulnerability? Okay, good. Those brand new to you. If you didn't know, OAuth had a session fixation vulnerability, and there was quite a few people using OAuth. And what it allowed you to do is, it was the way that OAuth handled sessions. So you could, as an attacker, request a session ID, and then if you got a user to click on the link in some way, shape, or form, which is a lot of violating things. If you get them to click on a link in some way, shape, or form, and they've already authenticated at some point, you can actually get them to validate your session ID, and now you have access to everything the same way they are. And I put the URL to the advisory in there, so if you're interested in finding out how that happened. The other one is Flickr, and I put the PDF up here because there was an API signature vulnerability, but it would take me almost as long to explain this as the entire talk. So I put the PDF up there. The guys that found it and wrote this up did a great job. So I'm not even going to insult them by trying to explain this. So now we're up to the evaluate portion. So we went through and we've thought about things about how to violate these APIs. So what is it expected to return to you? Does it give you an error? What does the error say? What is the return data format? What are the response messages? What do they look like? Look closely at error conditions. Invalid responses to invalid data can be really fun, right? So we supplied 127.0.0.1 to a URL location, and it returned something valid to us. That's very interesting. Pretty much anything when you're violating APIs, pretty much anything that takes an input should be looked at. But things that are really interesting are things that are static in nature. So if you can enumerate through things that appear to be user IDs or valid values from that perspective, or you can violate session in some way, shape, or form, or you can get somebody to validate some session data that you requested instead of a legitimate user did, and of course third-party connections. So from a developer's perspective, and I'm going to go through this kind of quick because I have a couple things at the end. I'm actually releasing an update to Monkey Fist too, so I'll talk about that for a second. But from a developer's perspective, threat model your APIs along with your applications, and start thinking about abuse and use instead of just use versus abuse, because that's usually what happens when at design time, when these APIs are being designed. There's a lot of thought on use, like how is this going to be used, and not a lot of thought on how can it be abused. So if you're threat modeling and you're identifying risks with something like Stride, and you're thinking about these things up front from the point of view of an attacker, a lot of these things won't come back as easily to haunt you. And that's a lot of what's not even happening in regular application development, much less when APIs are added to an application. Scope your APIs and know what kind of functionality you want to give to users, and how is it intended to be consumed. How is it integrated? Because obviously with the canvas, if you're rendering everything in the same canvas, you can call other applications built-in functions, which is probably something you don't want, or maybe you don't care about. So that's the other thing too. Risk is really funny. Sometimes you may not care. You may not care about your users. If you owned a monopoly, you may not care about your users. That's just the way it is. So it's all about risk, as with anything with security. So if you've evaluated that something is an acceptable level of risk, then hey, more power to you. And implement least privilege. This is important when you're taking somebody else's framework and implementing it into your application. So there may be functionality that you're implementing that you do not want users to have. Make sure that that is disabled and not able to be called. And of course, handle functionality properly. That would be a very good idea. And think about how you're going to pass session data back and forth. Proper design. Handling external content, same thing. Canvas issue, keep exposure areas away from main content. Don't integrate, somebody else's data in your domain. That seems easy enough, but it does not happen. Even RSS feeds, RSS data can be bad. And data and input validation. Back to the same things we're always back to. If it doesn't come from you, it is external, even if it comes from your friend. I mean, if your friend handed you a USB key, would you just plug it into your computer, or would you ask them what is on it first? Goatsy pop-ups are never fun. A few more. Don't put dev code in production. This is really big common sense stuff. And security test your stuff prior to release. Okay, now let's talk about something else. At Black Hat this year, I released a tool called Monkey Fist, and it does dynamic CSRF, because that's a lot of what me and Sean were talking about at Black Hat this year. And what it allows you to do is really interesting ways. And remember, you can CSRF API calls too, which is always very fun. It allows you to do some things that aren't easy to do otherwise. So for cross-site request forgery, there are certain things that were thought to be useful that ended up becoming not useful after this tool was released. You can basically set this up, and based on the referrer, it will go through your payloads file and hit a specific payload in that payloads file. Also, if you're leaking any kind of token data or session data, it will strip that out of the referrer and package it into the payload for you. It will also allow you to do things like hidden posts, which for a while there, people were saying, well, it's a post instead of a get, so it can't be CSRF'd as easy. Not really anymore. This is very easy to do. And it also, one of the things it'll do is it will fixate token data for you. So if there is some sort of token that is rendered on the page or gotten when you make a request for something, you can then take that token and append it to a user's request. So if you're just doing token type validation for cross-site request forgery, like you have this form token, if it doesn't have any knowledge of the session data, like the session ID, then it is useless. Because an attacker can just go make a request for a token, append it onto somebody else's valid session, and bam, your cross-site request forgery protection mechanisms are all gone. A couple of scenarios for that. The easiest one is a dynamic redirect. So if you're running number 3 with Monkey Fist on it, and it's not something, Monkey Fist is actually a knot, by the way. It's nothing like uber bad, so don't believe Urban Dictionary. So if you user requests content on a page, if you can implement content on good.com and send that data back to the tool will then redirect back to the user with valid session data, and then number 4 is the payload. I'm just going to go past post construct, because you can, if you leak full session data, the tool can make a post without the user's browser, the user's browser, and that's goodness. But the last two are dynamic page and session fixate or token fixation. So you can set up a dynamic page with Monkey Fist that the user never sees. So what happens is the attack happens, and then they're meta refresh to a legitimate destination. So like, let's say, for instance, you had a YouTube video, preferably not something horrible, and you're like, hey, click on this new YouTube video. When the user clicks on it, the attack happens in the background. They're meta refresh to the YouTube video. They have no idea that went on in the background, and that could be popular with like URL shorteners, because they won't know where their data is going. So the tool allows you to do that very easily. And then, of course, the fixation attack, where you can make requests for valid CSRF tokens and append them onto a valid session for a user and have that as well. The changes I made to make it 1.0 versus 0.4, which I released at Black Hat, were the other handlers now work, which they weren't even available to you before. So if you tried to call them with the tool, it would be like, this isn't implemented yet. So all it did was attack. You didn't have any options to just log things that came in, or to do a random handler. So if somebody was doing like SEO or something like that, they wouldn't be able to just pull random things out of the file. And the error handling is pretty good. So if you number a payload file wrong or something, it won't like totally crap out on you. However, the one thing I need to fix is in this fixation attack example, it assumes that all the input is type of input. So if you have something with the text area, it won't know how to do that. So I will fix that here at some point. And right now, I am pretty much done with this. Unless you have any questions, my information is up there, and Hopefully you stayed awake through the whole thing. I don't think I saw anybody sleeping, but I wouldn't know with the laser beam shooting in my eyes right now. Any questions? Sure. Why do you, I knew you were going to ask me about Adult Friend Finder. I don't know how much it costs a month, but what? You just wanted to ask me about that, like. Well, you see, I was on there doing research and sexy. Anybody have a real question? That was the weakest wrist I've ever seen in history. Oh, I have nothing to fear from him. Any other questions? I'm glad you're all awake. How many people went to the party last night? One person. I'm kidding. I was just saying that for camera. So, okay, cool. Quite a few. So that's good. I'm glad you got out of bed. Hopefully it was decent enough to get up for. All right, thanks.